developing unmanned vehicles, mainly for military applications, or robots for military applications. That's what my job is. So I thought I'd share with you the journey of how we've gone through the last 15 years or so. So as all of you know, see, my talk will not be any theory, no equations. There are not many professors coming after me who will be able to probably cover those topics. I get scared of equations and numbers, so probably I'll only stick to the final product, which is easier to handle. So we all know that unmanned systems are there in the air, underwater and on ground. So in DRDO, because I come from DRDO, I thought I'll just give an introduction who all are working on this. So unmanned aerial vehicle, primarily ADE or Aeronautical Development Establishment in Bangalore. They are making different types of aerial vehicles. Talking of aerial vehicles, in fact today is, I think ISRO is launching the hypersonic returnable, what do you call it, flight, like Indian space shuttle. Not the space shuttle, the first dummy aircraft, that's what I just read. And I think it was between 9:30 and 11, they had a window. So I don't know if it's already launched. It's a great event. ISRO is doing work on developing these products. And probably by the end of the lecture we'll hear whether it went up and came back down properly or not. So in DRDO we are working on unmanned aerial vehicles, not the type going into space, but closer to Earth. And we have ADE, then we have Vehicle Research and Development Establishment of DRDO in Ahmednagar. They also do work on aerial vehicles of a different size. Autonomous underwater vehicle mostly is handled by NSTL in Visakhapatnam. And I know I met your students from NIT and I know they are interacting with them. So they have made a flatfish design AUV, which is probably, if I'm not mistaken, some 3 tons. Okay. So a huge thing which is launched from a ship and is to perform under the sea. There are other people, of course, other than DRDO, like NIO, who are working on other underwater vehicles. In fact, closer to this place, even I know CDAC in Toronto is working on underwater vehicles. They have made underwater search vessel kind of thing with thrusters, and probably those of you who want to work in this area must visit CDAC and see what they have done. We are all government labs, okay, so there shouldn't be any problem in entering into any government lab, and they will be more than happy to show you. So, and coming to ground vehicles, we have 4 labs. Combat Vehicle Research and Development Establishment, which is CVRD, which is in Chennai. They work on, so what we have done is, these 4 labs, we have our own domain, so we have divided our work on weight, the easiest parameter. So we said anything over 10 tons, that is your battle tank, you want to make unmanned, CVRD will do, because they are basically into tank design, margin tank and all that. So anything, so they have made already an unmanned amphibious tank, which they have attained, I think, close to 10 kilometer teleoperation and autonomous behavior in the desert, not in cities. It's a completely different ballgame. If you come to in India, we have some, as I thought I'll just share with you, we have some collaboration going on with some foreign countries. So when the foreign expert or when our counterparts there, they come to India, and they're all interested in autonomous urban vehicles like the bus and this. When they come to India, they give up. They say that there's no autonomous vehicle which is possible. I mean, they say, how does your brain work autonomously to know whether the cow is going to cross now or the dog will suddenly come in the way? So we constantly do, our brains are, having that sixth sense probably to know when the scooterist turns left, he's going to take a left turn. There's no sign, there's no hand, there's no leg, there's no indicator. So you have to, it's built into our system how we drive. And the moment we see the first scooterist taking a right look, you'll be cautious that he's going to turn right. So that's on the lighter sense, but Then we have VRD, Vehicle Research and Development Establishment in Ahmednagar. They are working on trucks. So they made a Tata 2.5 ton truck, which is unmanned. We are in the middle somewhere. So anything from 100 kilos to 1 ton, we do. And CARE, Center for Artificial Intelligence and Robotics in Bangalore, they are working in anything below 100 kilos. But this is not, this weight distribution is not sacrosanct. We are also working on some things which are below 100. They are also working on something which are more than a ton. But we said, okay, if we have to develop product, we have to divide among ourselves so that we don't duplicate the effort and we do not step on each other's toes and say that I want to do this and why you want to do that. No, that doesn't happen. So we have distributed, and these are the DRDO labs who are working on this. Some of the pictures of already developed already developed unmanned vehicle. This is the Rustam. This is the Netra, which I'll be telling you more about. This is Nishant. This is another. This is, I think, the first one which KD developed. This can it's about 350 kilos weight. It is launched by a special launcher. This is the truck I was talking of, which has been designed by VRD. This is the tank of CVRD. This is our R&D's effort. This is from CARE, and this is a new project which is it's called HAIL, that is high altitude, long endurance. It will have number of hours of endurance which it can be. It's a much heavier class of aircraft which AD is working on. So all these are the different, some of the different products in DRDO. Now, before I come to showing you what we've done, UGVs or unmanned ground vehicles is what I'll be talking about mostly, except one UAV. But UGVs are mainly used for low intensity conflicts. Today you are not expecting a conventional war anywhere in the world. Like you had the World War I, World War II, and so forth. You have a lot of skirmishes, you have Syria, you have Afghanistan, you have all these places which are troubled. But basically these are low intensity conflicts. We call them low intensity means because there are terrorists and anti-national elements who try to, cause trouble. So these are where you can use these robots. Combat engineering is one branch of engineering in military engineering, in fact, which deals with mobile bridges, truck-mounted bridges, mine laying, mine breaching, buried mines. So all these are topics which are in combat engineering. So these are all hazardous. So whenever there is a hazardous task given, it can be done by unmanned assets. So combat engineering, there are some of these applications. Weaponized platform, obviously, is best. Why do you send a soldier? You have a weaponized unmanned vehicle if you can. There are certain robots which are hazardous, mission specific. I will be showing you some of them for chemical, biological, radiological, or radioactive material handling robots if you want to make. So those are mission specific. Communication is one area where to make repeaters, basically to increase your line of sight range. One problem, see, in the unmanned vehicle domain, the biggest problem faced by communication guys are the underwater waves because no RF goes there. So they have to rely on acoustic communication, which is very low speed. Ground vehicles are a little better off. You are above the water, but then you are faced with all the problems of undulations and trees, buildings. If you want to make a robot for urban area, you have problems of buildings and going into the building and how do you handle that. If you are building in for desert, you have sand dunes where the robot will go into a dune and you will lose communication because the antenna is not high enough. So you have to have communication robots which can handle these kind of scenario where you can make them as repeaters. Then you have reconnaissance and surveillance. These two are pretty similar words where you want to do a surveillance of a place and you want to carry out a recce to see what is happening there. You have robots which can be doing this. So these are all the application areas, military application areas. Keeping this in mind, so we started way back in 2000 and this building came about after 10 years after showing that we can do something, so the bosses had some faith in us, so then they sanctioned a building, and now we have a building where we are about 22 of us, all inclusive, everyone inclusive, we are 22. It's not grown in strength much, but then work has increased. I'll be showing you some of the work that we've done. And we have decided that we will make equipment for primarily aiming to combat engineering tasks, because military engineers, they have a lot of problems in the field where there is lives in many such operations. So we can build robots for them. We will make them also for counter-terrorist and counter-insurgency operations, which is very much required. Weaponized robots and other kind of robots which can carry the soldier's weight when he's going on a 72-hour march in the jungle. If you can give him an unmanned vehicle which follows him and carries all the load, probably he'll be more alert, probably he'll be more awake and more efficient. So these kind of robots are required. So we have aimed mainly at surveillance, that is material handling. IEDs are improvised explosive devices, which I think today has become a very known term. IEDs are your suitcase bomb, your something which is improvised. It's made using crude things, and then it is packaged in either in a bag or something which doesn't look flashy, and kept in a crowded place. So IEDs are one big menace today, not only in India, all over the world. You had the Boston bombing. You have bombing happening, IEDs going up daily in Iraq, Afghanistan, Syria. This is a menace which the world is facing today, and something has to be done to counter it. It's difficult because it's not an organized crime. It's not you don't know who's making it, who's planting it. The enemy is not known. So that's one area. The second, the next thing is UXO. UXO is unexploded ordnance. Unexploded ordnance is many times, we have a bomb, which is, for example, when the Air Force flies and does a sortie, and then the pilots are trained to drop the bomb at a location. They test the bomb, they train the pilots so that they know when to release the bomb so it will fall there and so forth. Many times the bomb don't explode because of whatever reason, manufacturing defect or something. So then these are huge bombs. So then how do you take care of it? So today what happens, the man goes risking his life because it's a live bomb. For some reason it has not gone off. And it is ticking. You don't know when it will go off. So it is very dangerous. So then if you have an unmanned vehicle which can go there and handle it, I will tell you what we're doing on that. Then you have this radioactive material and contamination, or chemical and biological contamination. Robots to handle such kind. So we have kept all this in our mind, and we started development. And I will tell you about the past and what we have been doing in the past, what we are doing now, and something in the future. Future and present has little blurred because we are somewhere in the timeline here. So I wish I'll be able to show you some of the concept prototypes which are already ready. So I'll come to the first robot that we made. This was in 2006. We completed. This is what we call Dutch Primal, and this is a 6-wheeled robot. It is battery operated. It can go on for 3 hours after recharge. It can be used in cross country as well as in urban area. It can climb stairs, go to buildings. It has a 6-axis manipulator arm which can extend up to 2.5 meter and pick up to 20 kgs at that point. Coming closer, you can even pick up 40 kgs or so. So any bag left in an airport or someplace, or in an airport, for example, in that what we call a belt, and someone leaves a suitcase, so who's going to touch it? So you have this robot which can go and handle it. Then it has a portable X-ray device which that we can fit onto that. So if you are very sure that it's a dangerous object, so you send it with the X-ray, you scan the inside, and if you find there's a battery and if you find there are wires, you're sure it's a bomb. So after doing the X-ray, there are 2 guns here. If you see here, there's this black rod which is there. That's called a water jet disruptor. So what we do is fill 100 ml water, just 100 ml water, less than a glass of water, and a cartridge is fitted behind and you fire. Now this gun is what it does is the water goes out like a bullet and it breaks. You can enter half inch of plywood, this much of plywood making a 2-inch hole. Just water can do that. And this gun we had imported previously, and our sister lab DRDO in Pune has just completed the indigenized, and we no more. I mean, all the paramilitary force and police were depending on the import. So this gun had a big story. It was like your HP, you know, where you buy the printer and you pay through your nose for the cartridge. So this also was a similar story. You buy the gun, which is cheap, and then you pay for your nose for the cartridges. These are different cartridges, of course. So these cartridges each used to cost 5,000 rupees. Even today, I mean, when I bought it first time about 10 years back, it was 1,200 rupees. So they jacked up the price 4 times. So about 2 years back, we decided that it's high time that we try to indigenize. We have just finished the first level trials. Now it's going to go further. So we will not cartridges already. If you make the cartridges in India, a 5,000 rupee cartridge will cost 50 rupees. So maybe 100 rupees, okay, and 50 or 100 rupees, not more than that. So we should have an indigenous equivalent. So we have started developing this. So using this water jet disruptor, you break open that parcel, you break into that bag. So in any explosive device, it's like all of you have seen your Diwali crackers. You have something called Sutli bomb, or you call it atom bomb, very loosely, not that atom bomb. So you have that bomb which has got string wound, you know, normally green color. I think all of you have seen it. So that's got some powder inside, gunpowder or some explosive material inside. So once it burns, it's just because it is tight, it causes a big noise. So if you open that string, keep the powder open and put fire to it, it will not burst, it will burn. So the idea is if you give it a lot of oxygen, it will get into burning. If you starve it of oxygen, it will get into the explosive. So the idea is the idea has to be burst open. I mean, that's really careful. And if you can, best is if you can disconnect the circuit, the electric circuit. It may be a circuit, it may be, mostly it's a circuit, and today most commonly it's either a timer or today most commonly they are using mobile phones. Mobile phone is the easiest communication device. So you can call up that phone and to the vibrator of the mobile you connect your circuit. Only thing that terrorist must be hoping he doesn't get a marketing call from some insurance agency and then he's gone. But they are using these. So this is the first robot which we made, and it also has a 12-bore shotgun. The shotgun is used to break through a locked door or a windshield of a car. You see a car is parked for 2-3 days and there is something inside. Then you want to break open and see. So this robot can break the glass, go inside and take it out. And we started development in 2002. Time given was only 30 months, 2.5 years, a very short time. And very short time, in fact, to search for the basic components to make these robots. So this is what it comprises of: the ROV, or remotely operated vehicle. Oops. Yeah, the remotely operated vehicle ducts. The control station, which is trolley based, it is controllable using RF from 500 meter line of sight. It also has a fiber optic link, because many times, because of today the mobile technology becoming so cheap and accessible, so you need to jam that area. So what army does is normally it uses a jammer, and whenever an ID is reported or a suspected bag is reported in these sensitive areas, they will jam the area. So nobody, your adversary may be sitting on top of a tree or building somewhere. When he sees people coming close, he will just give a call and the thing will blast. So you jam. So once you jam, we also get jammed because we are also in RF. So what happens then? You use a fiber optic link. So there is a fiber optic cable here. In fact, we got a patent for that because we had a big problem that 100 meter we want to lay out the fiber optic cable. How will you lay it out? Because your cable starts twisting. So we had to make electrical. You have slip rings. All of you must have had must have heard of slip rings, where you can put it at the center pin, and then you can again take out the connection from there. So what we did was, fiber optic slip rings are available, mind you, they are available. They are very, very expensive. Fiber optic slip rings, very good for these cable drums. So what we did was, we put all the converters inside the drum, and we put electrical slip rings on both sides, and we could take out the electrical signal, convert from fiber or from light to electricity, and take out the electrical signals to the electrical slip rings. We had a lot of problems. We had problems with interference, because you are taking out data. That is, to control the robot, there will be two-way data. So you will be getting video from the robot back. So there is video, which is in different frequency. You have audio, how your mobile, if it's, the mic starting tuck 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 tuck, as you heard in the morning. So this problem we had in the slip ring also. So whenever the robot used to do data transmission, you would have chattering noise. Yeah.
So why this hybrid approach of having both fiber as well as electrical? If you're using electrical, why can't we just?
No, we electrical to lay out some 100-meter cable carrying data, video, audio is difficult for 100 meters. You'll have noise problems. So you use fiber optics. It's lighter, because you have multi-core electrical wires going all over the place. So you'll probably require, I don't know, I have to calculate how many, but 6 to 8 cores. So 6 to 8 core cable will become thick, and it will become too long, and the communication will not sustain. If you have RS-232, or if you have 485, 422, you'll land up into some problem. So we have to convert to fiber optic. So that's why we made this, and we had to solve the problem of noise, that how the channels do not interfere with each other, the electrical signal, and we could solve that, and so this is now into production. It's a much cheaper, because an electrical slip ring costs less than 10,000 rupees. A fiber optic slip ring costs 35 lakh rupees. So it's a huge difference. So anyway, so this is controlled from this control station. It has a specially designed carrier vehicle. So what I would like to say is, think of the whole product. When the army said they want a robot, they meant only this plus this and probably some attachment. They never talked about this vehicle. So what we did was, in fact, I take industrial product designer in my team to guide with the development. Right? So we have some industrial product designers in Pune. I include them in the team, and they give a different perspective, because I tell you, because all of you might be engineers, but product engineer, industrial product designer has a different outlook, and I'm always amazed by their way of seeing things. Because when we wanted to take up this robot, I took help of the product designer. So when he came along and he says, we want to meet the user. I said, why do you want to meet the user? He said, no, we want to meet the user. You please facilitate that we can meet some of the army users who use these robots for diffusing bomb. We had met some of them, but we didn't think it was so important. But when I went to them, I found, wow, I mean, we got together in a bomb disposal company, I mean of the army. I interacted with them, and I said that we want to come and just talk to your people. And these designers said, we don't want to meet the officers, we want to meet the Jawans who actually use this equipment. So there were about 20 of them in a room. They were, so we gave a presentation that, see, we are going to make this robot and this and that. They had already the UK robot and the Canadian robot with them. So they said, we know, you're making indigenous. I said, yeah, we are making it. So we want your feedback and how do you use it. So the kind of questions he asked, that brought us to this thing. So he said, what problems do you face? Obviously, when you use the imported robot, can you tell us, is it good, is it bad, and all this. So one thing they said, that whenever we have to take the robot on duty, when we are called, it is weighing 300, 350 kilos. So we have a huge task of lifting that robot into a truck. You can't put a crane and all that, it will start damaging all this. It's a sensitive equipment. So then we came up with the idea, why don't we make a truck? It's not very expensive. We will include this truck like an ambulance, where the robot goes in, it sits inside, it has a ramp, it can climb in, it has a battery charger, And these people are going for a very stressful and life-threatening job. So you give them whatever comfort possible. It costs hardly anything in the whole thing. So we made this truck. I went to Tata Motors. I was thinking Tata Motors is huge. You will listen to me. And I want to make one truck. And but they were very responsive, and we made this truck. The interiors, what I had told them, the exterior should look like an army truck, mean outside and very soft inside. So inside is actually very soft. There is an air conditioner, there are 6 bucket seats, 8 bucket seats for the crew, there is a place for the robot, there is a battery charger, there is also a fridge. So why I kept a fridge was not for the cold drinks, but it is because the bomb suit which the people carry, they require ice. So this, when we interacted with these soldiers, we came to know. He said when we go, we have to carry ice and water. So in the bomb suit, it becomes very hot. That thing weighs more than 30 kilos when he wears it. It's very hot inside. So there is a pump and a water circulating thing inside. So they have to carry ice, they mix with water and put it in that pump. So we said, okay, we'll give you a fridge. So we gave them a small fridge, and there's a place for, there's a berth in case there's a casualty, anyone gets injured. There's a place for his rifle, and there's a generator set. And in fact, this truck got me into a lot of problems, because when we went for trial and we were showing this, nobody was looking at the robot. Everyone was interested in the truck. And the army guy says, whether we take a robot or not, we are taking your truck. Then I said, what is this? I mean, I have not come to sell this, I have come to sell this to you. So anyway, so ultimately, of course, because they found it that it's a super vehicle to go on a picnic. Because everything is there, you can carry everything with you and keep the robot back and you can go. But anyway, that's on the light note. So we first time did this, and I was saying in the morning, I went to many labs to look for help. Got some help from some labs. Primarily I got help from DRC because they already had experience. And we had to integrate multiple technologies, which was difficult. We started with a team. I started this robotic development with a team of the 3 of us. Director heard me when I was saying, and I was the instrumentation guy, and I had 2 assistants who were also electronics guys. Then I said, sir, you have to make robot. I need mechanical engineers. So he posted 2 fresh mechanical engineers to me. And they were right out of college, and they were very excited. So was I. So we used to say back, we started getting things like SolidWorks, and those of you mechanical engineers will know, learning about ANSYS, learning about dynamic analysis, learning about Nastran and Adams and so forth. So mechanical engineers were there, and we made our first robot, and then we went along that way. Then slowly I got an electrical guy, a communication, a lady who handles the whole communication and so forth. So, so it was difficult to take it from concept to a product in 30 months. Believe me, it was very difficult. For us, there was no holiday, because we are really very keen on succeeding, having the government giving us funds, and so the first robot we are trying to build, we said there's no coming back, we have to do it. So we used to work on Saturday, Sunday, whatever, and on 26th January we used to be in office. After the flag hosting, we were trying different things, because we enjoy the work. The main thing is you should enjoy the work, it's not as a job that you're doing. So, and then of course, we have established the transfer of technology to industry, now it's gone into production. So I'll just show you some of these. This was our first concept which I was talking about with a lot of backlash. I had a lot of problems getting basic components. Where do you get the wheel for a robot? So each of them has a story attached to it, that how we searched around, looked around, went to the cycle stand, scooter stand, looked for Bajaj wheel, looked for kinetic wheel. At that time kinetic had just come, to find out, is there some ready-made wheel which we can use? So it was very difficult. If you see, these are all Bajaj wheels, Bajaj Super. And then we graduated to Bajaj Chetak, which is similar to Super, and then we went, well, that time only those 3 scooters there. The third scooter was, this is kinetic, by the way. So we went along, and this was the first actuator, first robotic arm that we did. If you look at it, you will laugh, because it has huge backlash. When it goes, it jumps around. But then I could show my bosses that we could control, we could make something like this which is remotely controlled. This we made in 1 year, and within 1 year when the bosses, the people who matter, when they saw, they said, okay, you put up a project, we give you funds, make actually a real thing. So in 2002 the project came, the funds came, and that also I'll tell you an interesting story, because the imported robot at that time, the UK robot was costing 1.8 crores for one robot plus a controller from a company called Remotech. And now it is owned by Northrop Grumman, and Northrop Grumman is one of the biggest military hardware manufacturers. So we had a Northrop Grumman robot or a Remotech robot, and when we started the development, that was our benchmark. We had to be there. And so what do? We started with any project manager would know that you should never take one path. So we had taken two parallel paths. One, using imported motors, imported motors, gearboxes and so forth. And parallelly we started an indigenous effort. We said we should do it indigenously. And the interesting story is when I went for project sanction, why I told you about the cost was, 2 prototypes I had to make in my project, and I asked the committee, there's a committee which sits and you have to present and you have to tell, this is what I'll do, I require so much time and this much money. So I had put 3.5 crores I want for 2 and I want 3 years. So obviously there was someone who said no 3 years, 2.5 years. Then I said, okay, had I asked 3.5 years, you could give me 3 years. But that's a different story. I learned that the hard way that I was being sincere and then I was cut. Then they said, you wait only 30 months, you have to do. So I said, okay. And then the finance guy suddenly put up his hand. He said, there is something wrong with your costing. I said, why? Then he said, you are asking 3.5 crores to make 2 robots, which is including development. You will have some losses, you will have some rework, and 2 new robots of imported origin cost 3.6 crores. Where is your development cost? Where is your, you will have no money, you won't be able to do it. I said, no, that's enough money. So everyone started laughing, and the finance guy was even more amused. He told me, whenever I go for meeting, my work is to cut the funds. Here, first time I am telling you, you ask for more funds, and you are saying, I don't want money. So it was a funny experience, but the money was enough in fact. And we went through all these iterations, we made all these robots in that limited budget. And 2 parallel paths we took up because there was no precursor. I did not know where to get the motor, whether I'll get an indigenous motor, whether I'll get a drive, who do the electronics, so many questions were there. We went through iterations, refinement, and this was the first robot, in fact, without the arm. It was a 6-wheel vehicle with a camera which used to go around, and we were very happy at that time. And some of the key subsystems we designed in-house. The electronics, especially because probably my background is electronics, so that I said, no, we can develop in-house, there's no issue. We take help of industry right from the beginning. We design and we get it fabricated, or we get the PCBs done or populated from industry, because they do a much finer job in this. Then we write the software. All the software is in-house, the embedded software, as well as the GUI software. We also use industrial product design right from the beginning. And now I'll show you some of the trial photographs. So this was Daksh, which came about in 2006. May 2006 was my deadline, and I could finish in June 2006. It was 1 month delayed, but in June 2006 I wrote a letter to Army that I want to come for trials. This robot is ready. So Army was pretty surprised, and they called me for trials after about 7-8 months. So I was just waiting. In fact, it gave me some time to further refine, because any product, there's always scope for refinement. Always you think you can do a little better. This is not good enough. So then we went for trials, and we were called firstly to, it was in Pune in the College of Military Engineering, where they evaluated our robot, and they said, okay, it is ready to go for trials, it is working fine. And they sent us to Jammu. We went to Jammu. This is Jammu, the new rail line which had come up, and task given is, there is a magnetically coupled IED. They find this in those places. The anti-national elements come and just stick it and go near the fish plates, those where we join in the railway. So we were given that, can you cross? This is the first place we got into trouble. If you can see here, this my colleague is standing. It's very, very hot in Jammu. So I remember that the season was somewhere in May, and we were sweating it out, and this is the first problem. We realized that the railway track height is more than 8 inches. We go by train so often, but never give a thought to what should be the height, and we got bellied here. You can see the robot got bellied, and we had to tackle it, and it came back. So we found a way. We didn't give up. We told the user, you go at an angle. You go this way, that way, sideways, and somehow we could cross. But not happy, but we tackled this problem and we came back. So this was our first, some of the tasks. Then we were given this night operation. This is that magnetically coupled ID. They told us that the shepherds who go, the people who take all those votes and all, they come near the car and they just put it, and they have these problems. So they said, can you extract it at night? So we have a halogen lamp on that. Using that, you will be sure how it can be extracted. This is the NH1 going from Jammu to Srinagar, and underneath there are culverts. There are a number of culverts on the road. Underneath the culvert they put IEDs, improvised explosive devices. So this was one such situation. They put a fire extinguisher and simulating an IED, about 8 kgs. This had to go inside. You can see water is flowing and full of muck, very slippery muck. And it was raining, I remember that day. And every time the operator was asked to stand about 100 meters away. Here only the photographer was allowed to go near. The person who is operating the robot, he has to see on the screen with the camera feed. So there are 3 cameras on that. Using that, he had to control and take it out. So in our lab also, we used to have games where we used to say who can operate it better. So we used to say that, okay, the fellow who operates the best will be given a treat and all and so forth. So basically, we had some class 1 operator, class 2 operator in our group also. So any tough operation, you call him, Vishal. You have to solve it. He was good at trying. There are some people are good at games, you know, even in our video games. So then the next task given to us was a pressure cooker. They use pressure cooker as IEDs. Most of the Bombay blasts, by the way, in the local trains have been pressure cooker. Because pressure cooker is a good pressure vessel. It's highly compact, and if you blast inside, these pieces of this go out and cause the damage. So this was a simulated pressure cooker, and again it was a rainy day, and it's all covered with boulders in the side of a road, and we could see by the camera, and of course some of us were close and having a look, but we could not tell him, you know, take it right, take it left, nothing was allowed. So because they were trying to see whether really we can do it remotely, and to our horror we found it was a Hawkins pressure cooker. It was not a Prestige. Why I will bother, you tell me? It's because the Hawkins handle, and it was kept ulta, it was kept roundabout. So the Hawkins handle is right on top, the handle was right below, covered with boulders. And then at that time our robot did not have rubber fingers. I mean, we had not thought of it actually, to put rubber coating on the fingers. Now we have, and we have learned the tough way. At that time it was aluminium alloy fingers. So aluminium to aluminium, and it raining, we thought, gone, no chance. Because the moment he pulls up, it will slip because the handle is stuck underneath boulders. And this pressure cooker is not empty, it is filled with boulders. It's about 7 to 8 kilos. So, but to our luck, you see, slowly by slowly, Vishal, who was the driver, the operator, he could pick it out and take it out of the thing. Then we came back from the first trials in Jammu, and then not 1, not 2, but somewhere like 47 observations. Not 47 was a huge number. We were not at all, you know, dismayed by that. We said, okay, we'll go and sort out the trouble, and we'll see how we can improve the mobility and whatever problems we face. So what happened in the first trial, there were a number of army guys who are from Eastern Command, Western Command, Northern Command. I mean, these are different places in army where these bomb disposal units are there. So they kept telling me that your robot doesn't do this, the imported one does that. I used to listen, I used to say, okay. So then when I was called after the first trial, I was called to army headquarters, and there was a brigadier at that time there, and he asked me, he was Bengali by the way, so I can speak Marathi and Nepali, so I tried to make, you know, advantage of that. So I went and met him before, and I said, sir, I would request that you send the foreign robot also. In Bengali I asked him, you please agree when I asked in the meeting. He said, ah, no problem, no problem. Probably he was happy that, I don't know if it's a bomb connection or what connection. So when we had a meeting, I said, I want the next trial, I'll go back in 4 months. So everyone was surprised, 4 months? I said, yeah, just 4 months. They said, no, 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 I thought DRDO talks in years. I said, no, I'm promising I'll come back in 4 months, but you have to agree to one thing of mine, you please get a foreign one. Luckily, the boss over there, the brigadier said, yes, you take the foreign one. So I said, I know how bad our robot is or good our robot is. So they agreed and we went for second trial to Aknoor. This is Aknoor. The Pakistan border is just about 5 kilometers away from here. This is Chenab river flowing and this is the kind of terrain. So army wanted to test where, in fact that was also a good story because initially when we went for trials, the commanding officer was briefing us and then he said, gentlemen, all of you have come. This is DRDO who is offering this equipment. These are all the army guys who have come to test it. These are the quality assurance guys who are going to test the quality. Some maintainability chaps. All of you are assembled to see this equipment. We will see where it fails. So I immediately put up my hand. I said, sir, if you are going to see where it fails, I am going now. So he said, why? He said, sir, I told him, there is a list of specifications. Please ask the whole trial team to see whether it complies to specification. Not to overdrive to see whether it fails. Because if I give you a Maruti car, I can also take it to some slope where it's going to topple. And then you say it failed. So he said, okay, I mean where it fails within this specification. So it's very important that you convince the user or the operator to, you convince the final user that it meets the specification. So when we came up for first trial, first thing was the mobility was not good enough. Our thing had solid rubber wheels, which you had seen before. I'll show you some which have got teeth, which can help it to climb stairs. Whereas when you take that robot into this kind of terrain, it all gets stuck because the solid rubber teeth and it is thin. So when we came back, we had to look for tubeless tires, fat ones, which can distribute the load. And with this tire, we can go anywhere. And this tire and the other solid rubber wheel, it takes 10 minutes to change. You just jack it up. We have, now how do you change it? So in our lab, we said, okay, let's have a brainstorming. How do we change? So someone came by the wide thing, let's put YouTube and let's see how they change these Formula 1 car when it goes into the pit. You know, the car goes in, Formula 1 car, they go in and zoop, the tire comes out, zoop, it goes back. How do they do it? So we saw some videos and we got an idea that it's a single nut. They don't have 4 nuts like our conventional tires, which will take you 15 minutes to change. So we took some help from that, and if you see there's only 1 nut in the middle using which you can change. So we went with this. This is the solid rubber tire. This is towing trial. You can tow a medium-sized truck also. This is how it does the X-ray. And we went for a number of trials. First at Pune, then 2 trials with the user, then the maintainability guy comes from the army. It has meaning because see, these robots are going to be probably one in Calicut and one in Assam somewhere, one in Jammu and all over India. Who is going to maintain? So they have to see whether the equipment is maintainable. Is the design modular? Is it easy to change in the field? What can be changed in the field? What can be changed in the base workshop and so forth? So they come and ask you to open the whole equipment to the last nut and bolt, again assemble it back, and they literally take a stopwatch and they measure that if you want to change a motor, it takes 12 minutes. If you change a gearbox, it takes 25 minutes. And they have to note it down. And they said, okay, at the end of it, the report says that the equipment is maintainable. There is no problem. Then comes the EMI-EMC trial. EMI-EMC trial is for the radiation which is emitted or whether it is susceptible. This is also a tough trial to get through, where they see whether your robot is emitting some EMI which will affect other equipment, or is it that your phone starts ringing near the robot and the robot stops moving? Is it susceptible to other electromagnetic source at that point? So you have to pass that EMI-EMC trial, and then you come to the toughest trial, which is the quality assurance guys. They made my life miserable. After having the user was happy, they saw that the equipment is working. Maintainability guy said, very good, it is maintainable. You are given good handbooks, you are given technical manuals, you are given drawings. You have to give him everything. He sees all that thing. That because the maintenance engineer somewhere in India will only have the book with him, and he has to open and he has to learn from it how to open the equipment, which is the equipment to test, are the test equipment given, are there test points given, is there any indication to say this part of the thing as subsystem has failed, so he can ask for that subsystem. So all these things are checked. Then the quality assurance guy came in and he says, this was a big nightmare because there were about 18 quality assurance guys from 9 different quality assurance organizations. You have something called DGQA, Director General Quality Assurance, who look after the inspection and quality assurance in army equipment. So I was shocked actually when one Monday morning I come to office, I find 18 people in my office. I said, where are you from? So he said, from quality assurance. I said, what do you want to see? He said, sir, I am coming from so-and-so, I have to see the camera. I am from so-and-so, I have to see the vehicle. I am from so-and-so, I have to see your communication equipment. I said, okay, you are from so-and-so, so-and-so. They broke down this robot into, because it is multidisciplinary, there is no quality assurance agency which can handle such so many different areas of quality assurance. So they all were swarming on like bees on top of me, and I was really threatened because one guy said, sir, you remove the camera, I will put it in the chamber, because the robot has to work at -20 to +55. He said, I want to see the camera works. If there is fogging on the lens, if there is something else. Then somebody told me this is a remotely operated vehicle, so it's a vehicle. So I want to see what is the wear and tear in the tire. So I was out of energy at the end of the whole trial. I said, how to satisfy you guys? So we said, we'll do one thing. I'm not going to take out anything of the robot. We'll put the whole robot wherever you want. So luckily we found a chamber which the whole chamber can be taken to -20 degrees centigrade, and then we put the whole robot inside. We took a mouse with a long wire. It had a window. So the mouse near the window, we put the control station also inside, so you could see the GUI or HMI, you could see the PC screen. Only the mouse had coming out of the chamber. You had to operate the robot. So every electronics was inside except the mouse. So and we operated from inside. It worked. So we had to go through a lot of things with the quality assurance guys. We had to do mobility trial. We had to do going through ditches. We had to do sand dust trial, where for 1 hour they have a dust chamber, which is like a building with 3-4 pedestal fans. Whole place is dusty. They will keep that fan on for 1 hour, and then you take out the robot you are allowed to only clean the top part, open the thing and find if there is any dust ingress inside. There should not be any dust inside. So all those tests, rain tests, 1 hour of 8 showers onto this. First trial was a miserable failure because when 8 showers were put on and we kept it for 1 hour, and then we said confidently, okay, let's switch it on. So my operator was far away, I was with this qualification guy, so we switched it on and the robot started moving. I see it's moving. From there my operator is shouting at me, and my hands are up, I'm not touching it, it's going on its own. So if you're trying to signal to me, I'm not driving it, but it's going. And I kept thinking, see, it's going, it's all working and all that. So then I realized, oh my God, it's gone, become autonomous on by itself, There was no path planning or anything, but it was going. So we ran behind in the water and shut it off. We opened the cover and we found buckets of water inside. So the whole electronics were dipped in water. I don't know how it was working. So we were in tension, we called off the trial, we said we'll call you again. And the quality assurance guys had a nice smile and they went back. They said, okay, we can stay in Pune for 4 more days. So I said, yeah, you go and enjoy Pune, let me solve this problem. So we had to get through all the sealing problems and so forth. So before going ahead, I'll show you a video of what we do, make this video for the ad. Now what do you call for the exhibition? There is Jesse. So we made this small video where we go for exhibition and keep playing it. So there's a lot of crowd gather and they have to look at it. Nowadays they try to take selfies or not selfie on the mobile, they take the video picture. So it makes us feel happy that okay, they can see how it works. So this is, as you're seeing, the control station, and using with their joysticks. This is how it climbs stairs. It climbs up backwards, climbs down forwards. Basically, its weight distribution is such that it is heavy on the back, so it doesn't topple. You have to look into that part of the design, which is very important. Different types of tires which I talked of. It has skid steer, so that when you're climbing stairs and there is very less space in the turning or in the landing of the stairs, it has to turn in its spot. This is how it carries out